Do you see, guys, clearly the board, guys? Okay. So this time we're going to talk about derivatives of inverse trigonometric functions. Okay, guys? Inverse trigonometric functions. So, previously, in the previous video, I discussed derivatives of algebraic functions and trigonometric functions. Were you able to watch that already, guys? Guys, hopefully you were able to watch that because this is the continuation, the next set of functions. So, inverse trigonometric functions. We're going to um, get their derivatives. So let u equals f of x be a differentiable function, then the following formulas hold. The derivative with respect to the derivative of inverse sine u with respect to x is equal to the derivative of its angle with respect to x over 1 minus square root of 1 minus u squared. Remember, angles here are in radian measures, or they are real numbers. Okay, so if you think of them as real numbers, so it means they are directed lengths of arc on a unit circle. Then, if you have derivative of inverse cosine u, that is equal to negative derivative of u over square root of 1 minus u squared. Everything is with respect to x. The derivative of inverse tangent u is equal to derivative of u over 1 plus u squared. Derivative of inverse cotangent u is negative derivative of u with respect to x over 1 plus u squared. Derivative of inverse secant u is equal to derivative of u over u square root of u squared minus 1. Derivative of inverse cosecant u is equal to negative derivative of u over u is square root of u squared minus 1. Okay? So again, this is to remind you that u here are in radian measure, or u here is in radian measure, or um, or if you think of it as length of an arc of a unit circle, directed length, then u here is a real number. Okay, guys? Okay, guys, apat na lang tayo hindi pa nasagot. Hindi ko alam kung naririnig niyo ako. So, you have to remember these formulas. Now, these inverse trigonometric functions, inverse sine of u, inverse cosine of u, inverse cosine of cotangent, inverse secant, inverse cosecant. They are also called arc sine, arc cosine, arc tangent, arc cotangent, arc secant, and arc cosecant respectively. Kaya you review these functions, i-google nyo kung wala kayong copy kasi these were supposedly discussed in senior high, no? Inverse trigonometric functions, pre-calculus. Now, by the way, these derivatives of inverse trigonometric functions are based on the following ranges of inverse trigonometric functions. For instance, number 1, we have for inverse sine, we are going to use this restriction. Inverse sine is of u. So the inverse sine of u is between negative pi over 2 to pi over 2. And then number 2, inverse cosine u, the range is 0 to pi, meaning up from first quadrant to second quadrant. Number 3, tangent, inverse tangent of u, that is in the interval negative pi over 2 to pi over 2. Number 4, we have inverse cotangent u. So the value of this is in between 0 to pi. Number 5, we have inverse secant u. The range is 0 to pi over 2 union with pi to 3 pi over 2. And then finally, cos secant inverse has the range 0 to from greater than 0 to pi over 2 union with negative pi to negative pi over 2. Okay? So, again, these formulas are based on the following ranges of inverse trigonometric functions. Now, if you are going to take note of 5 and 6, other books make use of absolute value in the formula. There is an absolute value outside the radical, so that's absolute value of u. Then, also in inverse cosecant u. If you have absolute value, then you have to change the range for 5 for inverse secant and also the range for inverse cosecant. What you're going to have, um, first quadrant and second quadrant, what you are going to have for the range of each. Okay? So we choose these ranges for inverse secant and inverse cosecant so that we don't need to put absolute value outside. Is that clear, guys? Kaya baka kayo magtaka, may mga book naka-absolute value depending on the range that you are going to consider for each of inverse secant and inverse cosecant. So let us have the following examples. Differentiate the following functions. Number 1, So, mayroong ongoing construction sa katabi namin ng ingay. So, let's say we're given, number 1, y is equal to inverse cosine of 2x. Yan. So, what's the derivative? So, the derivative of inverse cosine is negative. Then, you're going to take the derivative of its argument, that is derivative of 2x. So, derivative of 2x is 2 over square root of 1 minus u. Our u is 2x. So, that is u squared. So, 4x squared. Okay, guys? Yan. Again, what's the derivative of inverse cosine 2x? Negative. Derivative of 2x, that is our u. Our u here is 2x. Yan. Derivative of that is 2. So, over square root of 1 minus the square of that. So, that's it. So, that's the derivative. Number 2, let's say I have f of x, and that is equal to inverse sine of, let's say, square root of x over, let's say, over 2. Yan. So, what's the derivative? So, our u here is what? So, our u is square root of x over 2. Let's get the derivative of u, because later we need that. Anong derivative ng u? So, that is 1/2. That is constant. And I will just take the derivative of square root. That is 1 over 2 is square root of x. So, what's the derivative of x? 1 over 2. Then, just copy the radical. So, and it is equal to 1/4 over 1 over 4 is square root of x. Okay? So, what is now the derivative of f? So, that is f prime is equal to is derivative of u. The derivative of u, this is square root of x over 2 is 1 over, yan, over 4 is square root of x. Yan, over square root of 1 minus square of u. But what is the square of radical over 2? That is x, root of x over 2 when we square x over 4. Okay? So let's simplify. So this is equal to, this denominator becomes part of this denominator of the numerator will become part of the denominator. So that is 4 square root of x. And then square root of, so this is equal to, getting the LCD inside the radical, 4 minus x all over 4. Yan. So, taking the square root of 4, so which is in the denominator of the radical, that is 2. So 4 over 2, so we get what? 4 over the square root of 4 is 2. So 4 over 2 is 2. So hence, the denominator now is 2. I can plug in square root inside. So we get square root of, square root times 4 is 4. Square root of 4 times square root of 4 minus x. So we get 4x minus x is squared. Yan. So that is square root of x times square root of 4 minus x. So x times 4, because same radical, x times 4 is 4x, x times x is x squared. Numerator is 1. Okay, guys? Number 3. What about y equals tangent inverse of 4x. Okay. And then this is raised to, let's say, 3. This function. Lakas naman ng tuk-tuk, no? And raised to 3. So this negative 1 is not exponent, huh? So it means inverse, okay? So here we cannot directly apply derivative ng inverse tangent because there is an exponent 3 in the inverse. So we're going to consider first this as general power. Drop the exponent, copy the base. So the base is inverse tan of 4x. Then subtract 1 from the exponent. So that is 2 times the derivative with respect to x of inverse tangent of inverse tangent of 4x. Okay? So, but what is the derivative of inverse tangent? So from there we can now write we can now apply directly the formula for the derivative of inverse tangent. And that is derivative of 4x is 4 over the square of this 4x squared plus 1. 1 plus square of 4x is 16x squared. So that's it. Medyo ayusin lang natin ang ating form, no? So that is equal to, if you're not convenient writing inverse tan, in this notation you can use arc tangent if you want. 3 times 4, that is 12. 12, then inverse tangent of 4x times, raised to 2 over 1 plus 16x squared. Okay? Guys, wala akong kausap yata. So let's have y equals, I'm going to change notation so that at least you know that it is possible, no? Arc cotangent. So it means also the same, huh? Inverse cotangent of square root of x squared minus 1 and then plus inverse secant or arc secant of x. So getting the derivative, what's the derivative of arc cotangent? Negative. I will have the derivative after, the derivative of the square root. So 1 over 1 plus square of this. What's the square? So that is x squared minus 1. times, instead of putting the derivative in the numerator, I will put the derivative after, I mean, after the derivative of our cotangent. I'll get the derivative of this, no? So, the derivative of radical is, yan. What's the derivative of the radical? Derivative of x squared minus 1 is 2x over 2 square root of that radical. So that is x squared minus 1. Okay, guys? Then, it is equal to what? Guys, let's just simplify because, I mean, there is another one. Second term, we have derivative of arc secant is derivative ng x is 1. Yan, over x, so that is my u, square root of u squared. So what is my ux? So x squared minus 1. Okay, guys? So, simplifying, we have 2x times this, no? So, 2x. But the denominator is, when simplified, this is simply x squared times 2. So, 2x squared, then square root of x squared minus 1. In the numerator, we have 2x plus 1 over x square root of x squared minus 1. Yeah. So, simplifying further, this cancels out, these two, with what? With 2 here, and together with x, no? So, minus 1 here. Okay? So, getting now, simply 1 over x square root of x squared minus 1 plus 1 over x square root of x squared minus 1, giving what? So finally, they are similar terms, so I can combine them into just one term, so giving 2 over x square root of x squared minus 1. Okay, guys? So that's the derivative. Okay. So let's have number 7. Let's say we're given y equals x squared, and then inverse secant of, or arc secant of square root of x. I want to find, let me have it as f prime. Let's say this is f prime, or I mean f of x, and I want to find f prime of f prime of, let's see, for square root of 5 minus, I mean, square root of 5. Yan. let me see, wait. We'll have square root. So that is, I think we have 4. Let me have 4. Kung 4 siya, square root of 5 minus 1. Dapat 5. 5 minus 1, 4. Oh, or 5 na nga. Let's see what happens if it is 5. Okay, guys? Let's have. What is the value of the first derivative when x is 5? Okay? Okay, first, let's get the first derivative. That is product. The first derivative of the second plus the second derivative of the first, that is 2x. So let me get the derivative of inverse secant of square root of x. So that is 1 over square root of x, then square root of this, square root, so square x, then minus 1, times derivative of that, 1 over 2 square root of x. Okay? Then, plus, for the second term, we have, just to copy, no? 2x inverse secant of square root of x. Okay? Yan. Dapat pala square root of, kung square root of 2 lang sana to, square root of 2, eksakto ang inverse secant. Ang inverse secant ng square root of 3 is pi over, let's see, kasi approximate natin ng calculator kung hindi eksakto. So, this radical is square root times square root, that is x. So, it is cancelled out with 1x here, that is cancelled with x squared, no? So, there is a remaining x. Okay, guys? So, this is minus 1. Yan. Minus 1. And then cancel with the radical. Did you get that, guys? Square root of x is x. So, x squared over x is x. So, that we have x over 2 is square root of x minus 1. And then plus 2x secant inverse of square root of x. No need to combine these two. Since once you combine, so you won't have things that you can simplify into simpler expressions. No? So let's now evaluate what's the value of this derivative when x is 5. Remember, derivative is interpreted as the slope of the curve at the point where x is 5 here. So if you're going to graph this, the slope of this at x equals 5 is the value that we will be able to get. So 5 over 2 times square root of 5 minus 1. So plus 2 times 5. Then inverse secant of square root of 5. Okay? Yan. So getting 5 over 2 times 2, because this is 4, square root is 2. So 2 times 2 is 5 over, so this is now 5 over 2. Plus 10, then arc secant of square root of 5. So this is the exact value. So if you're not asked to use calculator to approximate this is the answer. Or if you want to approximate, so where's my calculator? Now, inverse secant means what? So let me have here in a scratch. So if you let that theta, that inverse secant, square root of 5. So what is secant theta? Square root of 5. But remember, this is in the first quadrant. Inverse secant. Theta in quadrant 1. Because this is positive. If this is negative, we're going to take the theta in quadrant 3 as what we agreed. In contrast with the agreed range for inverse secant in other books, no, or by other authors. So other authors take the range from first quadrant and second quadrant. So what is cosine theta? That is square root of what? 1 over square root of 5. Okay? So we now take the inverse of this, no? So that we can get the inverse secant. Because this is not available in calculator. So that's why we convert it to what? To inverse cosine. I mean to cos in terms of cosine, so that we can take the inverse cosine of 1 over square root of 5. Or that is square root of 5 over 5. Square root of 5 or 1 divided by square root of 5 equals, then take the inverse cosine of that. Then we have to make it be sure you get value that is a real number or in radian measure. So what you will get in your calculator normally in degrees. Remember, we take the argument in real, as real number or as radian measure. So times pi divided by 180 degrees. So the value of this theta is approximately 1.107. Okay guys? Yan. So that's the value. Wait. Okay. May nagpa-admit. Therefore, what is our f prime of 5? So that is equal to, this is 2.5, no? 2.5 times what? I mean plus 10 times 1.107. So approximately times 10 plus 2.5. Approximately 3.607. 607. Take note guys ha, this is in radian measure. Or that's a real number or real number. Or that's a real number. Okay? That's it. You can have this or this, no? Next set that we're going to have Next, derivatives of logarithms and exponential functions. Guys, so you have to review properties of logarithms, properties of exponents. Okay, guys?